Hello again. All right, so we're going to continue now with this second type of proof statement for similar triangles. Okay, and we're asked to prove the statement that looks like this: AB, the proportion AB over QB equals BP over BR. Okay, so now we know that when we have similar triangles, the corresponding sides are in proportion. Okay, so I can look at this and say, all right, well, I got a whole bunch of triangles in this diagram. Which triangles do I need to focus on? All right, so I'm going to say, all right, AB. I'm not going to put congruence marks because I don't want it to look like I'm saying the sides are congruent. So I'm just going to say, all right, AB is here and QB is here. Okay, um, and BP is here and BR is here. All right, so that looks like if I prove those two triangles congruent, RBQ and APB, all right, I could then say, all right, well, the corresponding sides are in proportion. Okay, AB over QB equals BP over BR. All right, small triangle over large triangle. Okay, if you look at that proportion, that's the way it would work out. All right, so I spotted the two triangles. Now I just have to write the proof. Okay, so I've already written the proof for those two triangles up here. Okay, up here, that was steps numbers 1 through 4. Okay, if you see here for step 4, okay, RBQ is similar to PAB. Okay, RQB, APB. All right, so that's those two triangles. So I'm not going to rewrite the proof. All this would do is add one step to the proof. Okay. Um, so I've already proved them. Just one more statement, and the reason is going to be corresponding sides of similar triangles are in proportion, and it can be abbreviated CSSTP. So it's going to look like this. Okay, imagine I've already put in steps 1 through 4 from above. I'm not going to redo all that. So this would be step 5, and we would, whoops, 5, and then we would say, okay, AB, I have to do it this way, QB, okay, equals BP over BR. Okay, I have to write it that way. Okay, and my reason is simply going to be CSSTP. Okay, and that stands for corresponding sides of similar triangles are in proportion. Corresponding sides of similar triangles are in proportion. CSSTP. And that's it. So it adds one additional line. If the proof statement is just a proportion, you spot the triangles, you go through the regular triangle similarity proof. Like I said, it's 1 through 4 in this, in this example, it was 1 through 4. And my fifth step would look like this. It would simply be one additional statement with the reason CSSTP. Okay, so now we're going to look at the third possibility for the proof statement. Okay, and now in this case, you'll notice that this is the product. Okay, that is going to be a cross product that is the result of a proportion. Okay, it's asking to prove that the cross product that results from a proportion is true. So you need to first build a proportion that's going to result in that cross product. So we're kind of working backwards. We have the cross product. We got to get the proportion that would give us that. Okay, so I'm going to show you how to work backwards. Then we need to spot the triangles, okay, that we need to prove similar, okay, and then come back forward again. Prove them similar, say the corresponding sides are in proportion, and then our last statement would be this cross product, and our reason would be in a proportion, the product of the means equals the product of the extremes. Okay, so to build a proportion from this cross product, you have to remember that we're multiplying diagonally, right? So that means the AB and the AB and the BR in my proportion are going to be diagonally from each other. Okay, and the QB and the BP are also going to be diagonal from each other. So that's the proportion that would result in that cross product. AB times BR equals QB times BP. All right, which by design is exactly the one in this second example. Okay, it's the one I put here, the same one. So if this were your proof, okay, you would have steps 1 through 4 here, proving the triangle's similar. Then this would be step 5. You'd have to have the proportion, and then corresponding sides of similar triangles are in proportion. okay? And your last statement here would be number 6, all right? So I'll put it in here, number 6, okay? Maybe I'll put it down here. Number 6 would be, okay, I got to retype the proof statement, AB times BR equals QB times BP, okay? And my reason would be 6, okay, in a proportion, the product of the means equals the product of the extremes. Okay, that would be your answer. Okay, those two terms, by the way, the means and the extremes, that just means this. Okay, these two numbers, okay, this one and this one, those are known as the extremes in a proportion. Those two numbers, that's an extreme. This is an extreme. And then these two are the means. Okay, so the product of the means equals the product of the extremes. Okay, just as a fancy way of saying the cross products are equal. That's all that it's saying. The cross products in the proportion the cross products are equal. Okay, so that's it. That would be your last statement in a proof such as this. Okay, so far this is a lot to digest. So what I want to do is I want to just give you some practice dealing with each of these proof statements. We're not going to write the similar triangle proofs. Okay, finding an angle, two angles common to two other angles. At this point, you should be able to do that in your sleep. Okay, so we're not going to bother doing that for each of these. We're just going to do the last few steps so that you know what they need to look like. Okay, anything that comes before them is just a typical angle proof. Okay, so suppose I have this proof statement: PQ times CB equals RC times QB. The first step is going to be to find the proportion that results in that. Okay, so remember when I have a cross product, okay, the PQ and the CB are diagonal from each other. Okay, and the RC and the QB are proportional from each other. Okay, so from this, okay, I can see, all right, let's see, PQ is this one. Okay, RC is this long one. Okay, and we have QB is here. Okay, and CB is here. Okay, so that tells me it's going to be these two triangles, this triangle and that triangle. I got to prove those two similar to each other. Okay, suppose that takes 4 steps. Okay, to prove that the two triangles are similar, now I've taken 4 steps. So my 5th step now will be, okay, PQ divided by RC equals QB divided by CB. That's my proportion. Okay, so my reason will be 5 corresponding sides of similar triangles in proportion. Okay, and now that I've got that, okay, my 6th step, I have to write PQ times CB equals RC times QB. Okay, and my reason will be 6 in a proportion, the product of the means equals the product of the extremes. Okay, so that's what the last 2 steps would look like for that proof. All right, let's look at another one. AS times RC equals SC times QR. All right, so I'm going to build my proportion. Okay, first, I'm going to say, all right, AS and RC have to be diagonal from each other, and SC and QR have to be diagonal from each other. Okay, so now I'm going to look back up here. AS and SC. Okay, AS, it's AS and SC. Okay, and I've got QR and RC. QR, okay, and RC is this one. Okay, So that's going to be those two triangles, ASC and QRC, okay, which we did the proofs up here. Okay, we did those two proofs. We did prove those two triangles similar up here, okay, using, whatever statements corresponded to that. Okay, so suppose, again, it took all right, let's say it took 5 statements this time because you had to do the parallel lines thing. Okay, suppose it took 5 statements to prove the two triangles are similar to each other. That would mean step 6 would now be, it would be the proportion AS divided by SC equals QR divided by RC. Okay, and our reason in that case for 6 is going to be CSSTP. All right, and the last statement would be this statement, which is AS times RC equals SC times QR, and that is the cross product. Okay, so we are then going to say 7 in a proportion, the product of the means equals the product of the extremes. Okay, so that's that. Those would be the last 2 steps, assuming, again, that the proof of the 2 similar triangles took 5 steps. Okay, these would be steps 6 and 7. Okay, now one more. All right, so let's take a look at one more. Suppose my proof statement is now QR and RS. Sorry, QR times RS equals SP times PQ. Again, I'm now going to first get the proportion that would result in that cross product. So I know that QR and RS have to be diagonal from each other. And SP and PQ have to be diagonal from each other. Okay, so I'm going to look back up the diagram, QRSP and PQRS. Okay, so here's how you can spot the triangles easily. All right, I'm going to show you a little technique here. Okay, I'm going to get rid of these. Okay, we can look at this, and we can look at this 2 different ways. Look at all of the letters here. Okay, QRSP. All right, QRSP is not going to make a triangle. That's 4 different vertices. Can't make a triangle, right? And PQRS, same thing. That can't make a triangle. 4 different vertices can't be a triangle. So let me erase those. So if I look at them that way, it doesn't work. Okay. Or I can look at the letters this way. QRP and SPR. See, those are 3 letters, QRP and SPR. So I look up here, QRP, that's this one, and SPR, that's this one. Okay, again, we wrote that proof above also. Okay, but that's how you can quickly spot the triangles. Either look at the letters vertically in the proportion or horizontally in the proportion, and whichever one gives you 2 triangles is the one you can use. Okay, so in this case, it would be those 2 triangles. All right, again, let's suppose it took us 5 steps to prove the 2 triangles are similar. Step 6 would be QR divided by SP equals PQ divided by RS. Okay, and my reason for that would be CSSTP, corresponding sides of similar triangles are in proportion. Okay, and then my step 7 would be that final proof statement of QR times RS equals SP times PQ. And my reason, again, would be that, okay, in a proportion, product of the means equals the product of the extremes. Okay, and that's it. Okay, just to kind of show you the whole, looking diagonally and looking vertically again, looking up at these other 2. Okay, ASC, if I look at this vertically, ASC and QRC. All right, let's see. ASC and QRC, which triangles are those? Okay, ASC, that's this one, and QRC is that one. Okay, so that's how you can quickly spot the triangles. Okay, if I looked at that one horizontally, okay, if I looked at this one horizontally, let me just erase that and look at this horizontally. ASQR, that doesn't make a triangle. That's 4 vertices. And SRC, okay, if I look back up here, SRC is, that doesn't make a triangle either. Okay, that's three vertices in a line there. Okay, so that's not going to be the triangles. So that's why in that case you look at them vertically. You know, circle the letters vertically to spot the triangles. Okay, let's look at this one. PQRC. Okay, if I look at them vertically, PQRC, that's 4 vertices. That's no good. Okay, that's not going to give you a triangle. Okay, so instead I'm going to look at it horizontally like this, and it's going to be PQB and RCB. PQB, PQB, that was this triangle, and RCB was that triangle. Okay, so that's how you can quickly spot the triangles from the proportion. Once the proportion is built, you can use that little technique to find out which triangles need to be proven similar to each other. Okay, so that's pretty much it for today. All right, so take a look at the proofs in the homework. Okay, you've got, I think, one of each type to deal with on the homework. Okay, so good luck.